All right, welcome back. This is at THS, Mr. Jones, and today we're going to talk about chapter 3.4, which is on function operations and compositions. So this will be another section which is fairly easy compared to the transformation section that we just got finished doing. Okay, so let's start with function operations. Now, the first thing we can do is add two functions together. So let's say that I just let's put up here, I have f of x equals 3x plus 5, and g of x is, I don't know, let's just say x squared minus 1. So we can add these together, and that would look like f plus g of x, which tells you to take f of x plus g of x. Okay, and then we'll just add them. So you have 3x plus 5 plus x squared minus 1. You combine like terms and get it into standard form. So you have x squared plus 3x plus 4. Okay, now this you should have had an algebra 2. The main part that we want to really get into is the domain. So the domain when you add functions is the domain of f of x. Okay, it's that set of numbers intersecting with the set of numbers of the domain of g of x. So it's the intersection of your two domains, okay? And I'll talk a little bit about what that means once I get through all the operations. Okay, so then we can subtract the two, which would look like f minus g, or I could take g minus f, it could be either way, of x. That is f of x minus g of x. Okay, here's the trick thing, you're subtracting the whole thing. So when we substitute these in, we have to put it in parentheses. Okay, because then it becomes, distribute that, you have negative x squared plus 3x plus 6 for your solution. And again, the domain for this is the same as this. So you want the set of domain of f of x intersecting the domain of g of x. So where are those common points? All right, we can multiply our functions together, and that would look like, we can look at it a couple different ways. It'll be f g of x. Sometimes we just write it f g of x, and that means you're going to take f of x times g of x. Okay, so you have 3x plus 5 times x squared minus 1. And then you would distribute that all out. You get something like 3x to the third plus 5x squared minus 3x minus 5. And once again, our domain will be the domain of f of x intersecting like f divided by g of x, which is f of x over g of x. So in this case, we would say 3x plus 5 over x squared minus 1. And that would be our answer there. We're not taking it any further than just writing it like that. Later on, we'll factor it out and we'll cancel some things and that kind of stuff. So the domain for this one is similar to these, but you may notice that down here I may have a problem. Since I have a fraction, we've discussed many times that this down here cannot be 0. So we will look at the, we're going to say the domain of f of x intersecting the domain of g of x, intersecting the set where denominator does not equal 0. Okay, in this case, it would be intersecting the set where g of x does not equal 0. So you have to take out the number that make this 0. Okay. Now, what this briefly talks about is these intersections. So let's say that, let's say my f of x domain is negative infinity to infinity. Okay, so that's, if we draw that over here, 0. So my f of x is covering the entire graph. Okay, and let's say we have we've got this g of x here that has a domain of, let's say we've moved it a little bit around, and I have that its domain is -5 to infinity. Okay, so here's -5. We'll have a closed circle there, and it will go to infinity. Okay. Now, the domain of each one of these, okay, if I want to say what's f of x plus g of x, the domain of that would be the intersection of these two graphs. So where are they overlapping one another? Well, they're overlapping from here on. So in this case, my domain would be -5 to infinity. That's the intersection. So we have up here, we said the domain of f of x, which was this green line, intersecting the domain of g of x, which was the purple line here. So where they overlap is my domain of each one of these, whether it's adding, subtracting, multiplying, dividing. Now with dividing, we'd have to get rid of whatever made this equation 0, which in this case is probably this -5. Okay, that -5 is probably making this function 0. So if I were to do f of x divided by g of x, okay, the domain of that would most likely be just a parenthesis instead of a bracket there. But you have to look at what the actual equations are. Okay, so even this one, if I did it the other way, -infinity to -infinity, which is the domain for this, or for this one, okay, I'd have to get rid of whatever made that 0. Well, that would be -5/3, so I'd have to get rid of that number alone. Okay, I want to go ahead and read you the questions. Question 1, if you get a 20% discount for being an employee, plus you have a 5% discount coupon, what would you pay on a $45 pair of jeans? Okay, you might have to rewind it and listen to that again. So that's question 1. Question 2 is, how will you find the domain of f of x divided by g of x? Okay, so those are your 2 questions. We're going to go on to composition of functions. Now, composition of functions basically just functions within other functions. So instead of plugging in a number into a function, now we're going to actually plug in equations into other functions. So the first one we have here is f of g. Okay, that's how you read that, f of g. Okay, sometimes I'll put an x on there as well. So it'll be like f of g of x. So what that is telling you is you're going to take f of g of x. So this is saying you're taking x and you're going to plug it into g, then you're going to take that thing and plug it into f. Okay, so it's a lot of things. So let's say, for example, here we'll say f of x equals 3x plus 5 again, and g of x equals x